we can see
Is
your
this
screen.
okay? So like my name is Vinayak Sharma, and my project is whiteboard integration for GSoC 23, and my mentors are Shiqi and Douglas Gubert. So like let's talk about what this project is. So whiteboard integration is a project built for providing whiteboarding features within users' workspace using Excalitur's existing solution. So like you might have used whiteboard before, like Miro whiteboard, Collab mode, and Excalitur, but we want to integrate this whiteboard into the Rocket.Chat only. So like we don't have to use any third-party app for providing whiteboard experience. So yeah, these are some of the points why we need this project. To use whiteboards, we have to rely on third-party sources, and most of which are not open source. So like Excalitur solution is open source, so we decided to go with that. And most whiteboards store your data in a browser cache. So like there is no permanent record of your data. Like if we remove the cache, we can lose our data. Sometimes the whiteboard ideas are critical, so we want to keep them in our workspace. And like we have to like start up quick our workspace. Like we have to share our ideas quickly, so we can do it with this app. What are some of the current features of a project? We can use slash commands or action buttons to start up a new whiteboard. We can store real-time previews of our boards. We can modify settings to edit the board names. We can modify the permission system to make the board public and private. And we can also store external files and images in our boards. So let's take a demo of the project. So like this is the workspace general channel. So and this just starts up a new whiteboard for us. We can go and click on this edit board, which fires up a new Excalitur screen React app for us. We can start editing on this. And what you'll see now is we can store the real-time previews of our data as a preview image. And so like we can also upload file images also here, and which are also stored in our previews. So yeah, that's the one of our main features. So let's talk about how this all works. So like this is the architecture of our whiteboard app. We start with Excalitur client folder. We bundle our whole React app into JS and HTML files, and we then serve them on the two endpoints of our whiteboard app. JS files on the bundle.js and HTML file on the board. We can then use uh, the get route and the update route to get the board data from directly the Excalitur app. So here we can like get our data when initially like if we so if this data is stored in our persistent storage. So whenever we refresh or reload the board, this data gets loaded into our workspace. And these assets are what makes the Excalitur app work in the browser. And the Whiteboard app makes and sends and updates the Rocket.Chat messages. We use like Rocket.Chat UI kit for registering all the buttons and the attachments in the messages. And we like store all the data in the Rocket.Chat app storage. So yeah, that's how the basic architecture of the app is. So like some of the difficulties we faced during the project. Our earlier project was using iframes. So like iframes. So like initially we used Whiteboard to generate a screen here which we could edit. But later we realized that it was not feasible solution because when we load our workspace or when we reload our page, all the workspaces get start up at the same time. So like it takes a huge load on the server. So yeah, we decided to take this new approach where we decided to serve on the whole React app on the endpoints provided by the app. And yeah. So we use Webpacks to bundle our whole client app and serve on the Rocket.Chat endpoints. And there was one more difficulty, like how did we store images? And how did we store images? So like this was a really difficult part because we had to generate some previews in base 64 format of all the images we stored and all the previews we generated. So like for the files too and the drawings we made and other things. So yeah, and those external files in the storage. Some of the future goals of our project is to implement the live collaboration feature. It's a like a really complex task because the Excel draws. Let me show you. So yeah, this is the Excalibur workspace, and this live collaboration is based on WebSockets. But currently, the RC apps engine doesn't support socket. So we have a solution in mind. So like we can use HTTP long polling for implementing a solution between WebSockets and REST APIs. And one more feature we plan to implement later is a context bar to showcase all of our boards for better management. And one more feature we have in mind, like we can make the uh, to control the permission of our boards. So like this board has been made private. Like if someone wants to keep his ideas to himself, uh, we have that solution too. We can just use direct chats here to showcase our ideas and generate whatever we want to. Yeah. So this was our team and mentors. Thank you. Uh, if you have any questions, please feel free to ask.
Vinayak, I actually have a question. If you can just go to the architecture slides,
Okay.
it was a bit small for me. So
Okay.
maybe you can move it to the slideshow or
Yeah. Mm,
on the
oh,
corner
sorry. Yeah.
right. Yep.
Yeah. Yeah. Sorry.
Uh, just I couldn't read it during the presentation. If you can go over the architecture again for us, please.
Yeah. Yeah. So like we know the apps engine is a server-side environment for generating the apps, but we realized in our iframe solution that that would not work out and would not be a scalable solution. So we decided a client and server approach, where the client will be the Excalibur client bundle, which we generated using Webpacks, and then we serve those HTML and JS files on the endpoints provided by the apps engine. So like it's not a typical approach for the client server because in client server they are interacting at the same time. But here we generated a whole React app in a single file and served them as an endpoint. And then we use other get and update endpoints to interact with those other files. And then we can get all the data like on the files uploaded and the drawings made as a preview back from the app. And then we store all the data in the Rocket.Chat app storage. We use like Rocket.Chat UI to register all the buttons and the settings, and we send and update messages through the Rocket.Chat. So yeah, if you have any questions, please free to ask me again.
I see a question there on the channel from Kevin. Is the image you send coming from Excalibur or it's being dynamically generated on the app sides?
Yeah, so like the image is coming directly from the escalator. We generate a base 64 preview of the whole board that we have currently the elements in. So like if we update, uh, so yeah, so if we all the like elements, the space occupied by all the elements are used to generate the boundary of the base 64 image preview. We send this side. So yeah, it's from the escalator side.
Yeah, that's really interesting. So we are basically hosting another app inside the apps engine.
Yeah,
That's
sort of.
yeah. Uh, what happens when multiple people are editing that? So that was the long pooling you implemented, make it multi editing available then?
Yeah. So like this is one of our future goals to like implement WebSockets and collaborating like real-time collaborating abilities of the escalator. So like we could be one user could be making some drawings here and other user could be making, and the both users would be highlighted and their progress could be like sort of reconciled to avoid overlapping of the data and like saving the data to the Rocket.Chat.
That's cool. Thank you and congrats for that.
Yeah.